The first step that we always follow to find a partial fraction decomposition of a rational function is to factor the denominator completely. So this denominator has a common factor of x. And so we can just pull that x out, and we're left with an x squared plus 4. Now, x squared plus 4 is an irreducible quadratic. And when we're factoring for partial fraction decomposition, we want to stop at our irreducible quadratics. So our denominator needs to be written as a product of linear factors and irreducible quadratic factors. Then we're ready to set up the form of our partial fraction decomposition. X is a linear factor. So we know linear factors, we just get some unknown constant on top. However, x squared plus 4, that's an irreducible quadratic. So we're going to have a fraction with that in the denominator, but our numerator is no longer just an unknown constant. It's actually an unknown times x plus some other unknown. Okay, so this is always going to be something times x plus something for the numerator of a fraction with an irreducible quadratic as the denominator. So this is our form of the partial fraction decomposition. And now we're ready to multiply both sides by the denominator here, x times x squared plus 4. And of course, on the left side of the equation, that should always do the same thing for us. We should always be able to cancel that out completely. And we're left with our 2x squared minus x plus 4. And on the right side, we take each of these terms and multiply by that. So a over x times this, the x is going to cancel. And we're left with a times an x squared plus 4. With this second term multiplied by that, we will cancel the x squared plus 4 out. So we're left with bx plus c, and then that times x. Okay, now at this point, when you're dealing with irreducible quadratics, I'd recommend just going straight to expanding everything out. So the left side of the equation is already expanded, and nearly always will be. The right side, we just multiply everything out. So a times x squared plus 4 times a. And then here, multiplying the x in, we get plus bx squared plus cx. Now we are going to group our like terms on the right side of this equation. So we've got here a ax squared and a bx squared. So when we combine those, we have, and factor the x squared out, we have a plus b times x squared. And then we have just this x term plus cx, and then this constant term plus 4a. And we have terms just like that on the left side. We have an x squared term. We've got our 2x squared, and we've got an x term minus x, and we've got a constant term plus 4. So what that tells us then is the coefficient of the x squared on the right side has to equal the coefficient of the x squared on the left side. So a plus b has to equal 2. Okay. And similarly, the coefficient of the x on the right side has to equal the coefficient of the x on the left side. Okay, so that's c has to equal -1. And then finally, the constant term on the left has to equal the constant term on the right. And so that tells us that 4a has to equal 4. So you end up with this system of equations to solve. And this one is nice and easy. We already know c. We can get a here by dividing by 4, so a equals 1. And then if I plug that into this first equation, I have 1 plus b equals 2, so b is equal to 1. So we know a, b, and c, and we can plug those into our partial fraction decomposition here. So for our final answer, we have our original. And I like to always write my original so that I know kind of what I was doing. Okay, equals a over x plus bx plus c over the x squared plus 4. And there's our partial fraction decomposition.